Photoelectric effect. Photo means light, electricity means flow of electrons. For light, flow of electrons we are getting. So that is why it named as photoelectric effect. So let us see this photoelectric effect first identified by Hedge. It is unfortunately happened. Later on, Hedge and Leonard observed experimentally. So this is very important topic. So that is why I will cover each and every point. So it's a little bit theoretical one. So I'm explaining little bit slowly. If you want, you can increase your video speed. See here, Hedge, while he is doing research on ultraviolet rays and their effects on the materials, unfortunately he identified while he is illuminating this light on zinc plate, he observed electrons came out from zinc plate. So for that light, high frequency of light, ultraviolet rays incident on the metal and electrons came out. So that is why he named as photoelectric effect. Later on, both studied and identified the factors affecting this photoelectric effect. Let us see definition point of view. So photoelectric effect they defined in such a way that when a sufficient frequency of light incident on the metal surface, then that sufficient frequency of light can pick out the electron from the metal surface. So this phenomena is called photoelectric effect, means the emission of electrons from the metal surface when illuminated by a light of suitable or sufficient frequency or wavelength of light. So here we are getting the electrons. Those electrons we are calling as photoelectrons, and the metal used is photometal. Here in this diagram you can see light rays of sufficient frequency incident on the metal surface. The free electrons on the metal surface will come out from the metal surface. Next, if you see experimental study, what factors affecting this photoelectric effect? So for that they arranged one experimental setup. So that a setup, if you observe, it is an evacuated tube. So completely airtight evacuated tube they consider, and they allowed the light to pass on a metal, photometal C, nothing but cathode, and one more plate they arranged at other end of the tube, A, metal A. So if sufficient frequency of light incident on the metal, then this photon of light can pick out the electron from the metal surface. Those electrons can travel and they can reach metal plate A. So then according to the circuit, here that microampere current can be identified. Here electrons flow is less, so that is why minute current will come, so that is why microammeter required. So then we can identify the small current also. So here by taking the battery, whenever electrons came out of this metal plate, those easily can reach. For example, due to collisions, if some electrons stopped, those also can be gathered by applying positive potential. Here you can see positive potential applied. So if you increase the potential, then all electrons will be reached. Here you can see how much voltage we applied. And further, whenever we want, we can change the polarity of the batteries in such a way that the arrangement will be there. Let us see. So here with this experimental setup, what factors they identified? The first one is the factors affecting the photoelectric effect. The first one, potential difference between the two electrodes. So here in the diagram you saw already. So once again the diagram. Here plate C and A. So these two are maintained at a particular potential by using a battery. So if you change the potential, then photocurrent will change. Just now I explained, if you increase the positive potential of plate A, then that plate A can attract the negative charged particle electrons, then all electrons will reach the plate and we can observe more current. And one more, the intensity of incident radiation. So here intensity means number of photons incident on unit area in unit time. So here we are increasing the intensity, means for suppose increasing or decreasing, both options are there. For example, if you increasing the intensity, then number of photons will increase. So one photon here can pick out one electron, then if you are increasing the number of photons, means number of electrons will come out. So here one photon can interact and it can pick out one electron. That statement given by Einstein, so those details will come later. So here presently, if you increase the number of photons, number of electrons increases, number of electrons means the flow of current increases. Next, third one, frequency of incident radiation. So here frequency increasing means we are increasing the energy of the photon. If energy of the photon increases, then some amount of energy is utilizing to come out of the metal surface. The total remaining energy utilized as kinetic energy to the electrons. So electrons can come with much velocity. So frequency increases, then kinetic energy of electrons which are coming out of the metal, photometal, will be high. So frequency also affecting the photocurrent, means electron can come quickly, means fast flow you can observe. Next, fourth one, nature of metal used. So here they studied experimentally first on zinc plate. So afterwards they got out only this effect given by zinc plate or other metals. They studied on different metals also, and finally they observed that as compared with other metals, 1A group elements, those metals are giving this photoelectric effect easily. Why? Because if they lose one electron, that is outermost electron, only one electron will be there in 1A group elements, so that electron easily they are ready to give to get octet configuration, to get the stability. So that is why on those metal just ordinary visible light, red and little bit more energy light is enough to pick out the electron from the metal surface. So different metals are giving this effect in different way, means some metals with less energy they are responding. So here in the definition is that sufficient energy required. So less than the sufficient energy means this photoelectric effect can't occur. So the minimum energy required, so that minimum energy is different for different metals. So some metals can show this effect easily, some metals are not showing easily. So that depends upon the minimum energy required to pick out the electron. So those factors we discuss one by one. First one, the potential difference between the two electrodes. Let us see. For example, here as it is supply given, and here the positive potential, for example, we are increasing continuously. As we are increasing the positive potential of A, so any electron stopped in the middle due to collisions between the electrons, so those also will be gathered. So as we are increasing the potential, the current increases rapidly, and afterwards further there is no chance to increase. So continuously the current can't increase. Why? Because here the number of electrons are fixed. Why? Because here intensity fixed. So for a fixed intensity of source, you are getting fixed number of electrons. If they stopped in the middle, those also will be gathered due to the positive potential given to this plate A. So if you study that one graphically, then you will get a graph like this. One, say for example, if the potential is 0, for example, even then you can observe some amount of current here. But if you increase the positive potential to the plate A, then current increases sharply little bit. Further it will reach to a maximum value, so further it can't increase. That maximum current is called saturation current. And now if you interchange the battery polarities, then A will get negative charge and plate C, photometal, will get positive charge. In this case, so whenever we are applying the negative charge to plate A, then electrons will face negative plate. So repulsive force will come. So due to the repulsive force, electron velocity decreases and continuously. If you are increasing the negative potential of plate A at a particular negative potential, then total photocurrent will be 0. See, on y-axis the value 0. So for a particular negative potential, the total photocurrent 0, that particular negative potential is called stopping potential. So that one as a definition, the negative potential at which the photocurrent becomes 0, that is called stopping potential. Next, so this is about potential. If you change the polarities also, we can get this effect like this that we discussed. Now second factor, intensity of incident radiation. So I said already, intensity of incident radiation means number of photons incident on unit area in unit time. So increasing intensity means we are increasing number of photons, decreasing intensity means we are decreasing number of photons. One photon if you consider as h mu according to the diagram. So initially the diagram graph you studied already, so that one once again, if you analyze in another way, if you increase the intensity continuously, then photocurrent also increases. Number of photons if you are increasing, number of electrons increases continuously, it means photocurrent increases continuously. So here it is proportional. So here intensity and photocurrent both are proportional, that is why we got the straight line. Okay, so the photocurrent is proportional to intensity of incident radiation that they observed experimentally. And one more, that if you are increasing continuously the intensity but we are keeping frequency remains constant, for suppose in that case if you are maintaining constant frequency but we are changing the intensity, in that case, so I said already frequency remains constant but intensity is changing continuously. For example, I1 is the intensity. For a particular I1 intensity you will get the graph like this, but if you increase the intensity, so here I1, I2, I3 continuously, I3 is much more greater than I2 and I2 is greater than I1. So like that they consider different intensities. So as compared with I1, for I2 we got more saturation current, for I3 much more saturation current. So saturation current means maximum current. So the maximum current depends upon intensity. So that is why we got a graph like this. But here you can see all graphs are meeting at a particular point, means stopping potential is same. The negative potential, the stopping potential is same for all. Reason, here we are increasing the intensity, means we are increasing the number of photons. Due to the increasing number of photons, current increases. So that is why different high levels of current we observe. Photocurrent is high, but frequency remains constant for all, same energy. So same energy means kinetic energy of all the electrons is same. So to stop these electrons, the potential required is also a constant. So kinetic energy of electrons constant, so potential required to stop those also constant. So that is why here we got same stopping potential. Means here we can say one point, stopping potential is independent of intensity of incident radiation. So the points if you mention once again, so here stopping potential is independent of intensity of incident radiation. But one more point here we mentioned about saturation current. So saturation current is proportional to the intensity of incident radiation. Next factor, that is frequency. So frequency of incident radiation, if you increase the frequency, what will happen? Let us see. So here on x-axis consider frequency, on y-axis stopping potential. So why? Because if you are increasing the frequency, kinetic energy of electron increases. Why? Because a constant energy required to pick out the electron from the metal surface, so the total remaining energy will go to kinetic energy. So to stop that kinetic energy of that electron, we should apply the negative potential, that should be much more high. As we are increasing the frequency of incident radiation, we should increase the stopping potential. Okay, so if you study here, the lowest frequency what we are observing here, the minimum frequency required to liberate the electron from the metal surface, that is called threshold frequency. The minimum frequency required to liberate the electron is threshold frequency, the minimum. So more than that if you give, then that electron will get kinetic energy more. To stop that one we have to apply more stopping potential. Okay, but less than the threshold frequency if you give to the metal surface, then we can't get any photoelectric effect. Now based on that, here what we discussed, minimum frequency required just to liberate the electron from the metal surface is called threshold frequency, and the minimum energy required is called work function. Okay, so here work function is the minimum energy required. Next, same thing if you study for different frequencies, then the graph will be like this. So here graph depends upon potential and photocurrent. So first graph for frequency and stopping potential, but here graph between potential and photocurrent, but intensity remains constant. Okay, so here intensity remains constant, so number of photons constant, so that is why maximum current, saturation current is a constant. But different frequency means different energy. So for example here low frequency, so less stopping potential, but here more frequency, so more stopping potential required to stop the electron in this case. So that is why we got different stopping potentials. So if you increase the frequency, stopping potential also increases. This is the proof experimentally. Next, just if you compare with the last graph, so both are looking like same. Why? Because the three curves are there, but difference is there. So here frequency constant in this graph, but intensity variable. So different intensity, different saturation current, but same frequency, so same stopping potential. But here same intensity but different frequency. So due to different frequency, different stopping potential, due to same intensity, same saturation current. That you should compare carefully. Next, last one, nature of photometal used. So I already said, if you use different metals, if those are 1A group, so those metals will respond quickly to give the photoelectric effect. Why? Because that outermost electron is loosely bounded with the nucleus, so easily for less amount of energy of photon also that electron can come out from those elements. So that is why, so you can observe potassium and sodium. Sodium atomic number 11, but potassium atomic number 18, so outermost electron is little bit away from the nucleus, so that is why easily we can pick to the electron from this potassium. So that is why less frequency is enough to pick out the electron in potassium. So that is why graphs for different metals. So nature of the metal also will affect the photoelectric effect. So work function, so minimum energy required, that is work function, is different for different metals. Next, all these what we discussed, if you analyze one by one, those we are calling as fundamental laws of photoelectric emission. The first point, photoelectric current is proportional to the intensity of incident radiation. If you increase the intensity, we are getting more current. I said already, intensity nothing but more number of photons, so more electrons will come out. So that is why photocurrent increases. So proportional. Next, the minimum energy required just to liberate the electron from the metal surface is called the minimum energy required, that we are calling as work function. Next, the minimum frequency. So here minimum energy in the second point, but instead of energy, for example, if you analyze with respect to frequency, that minimum frequency required just to liberate the electron from the metal surface is threshold frequency, and the corresponding wavelength we are calling as threshold wavelength. So here minimum frequency required or maximum wavelength required. Why? Because both are inversely proportional. So maximum wavelength required, that is threshold wavelength. Next point, the maximum velocity or kinetic energy of the electron depends upon, so velocity or kinetic energy to the electron we should give. So the energy of photon should be high, then only energy means that is frequency. So frequency of incident radiation. So maximum velocity or kinetic energy of the electron depends upon frequency of incident radiation. And one more major point, so far we did not discuss that one, that is photocurrent is independent of its temperature. For example, if you increase the temperature, we can get the electrons from the metals, but that is thermionic emission, not photoelectric effect. So that is why both are completely different phenomena. So photocurrent independent of its temperature. Next, one more point. Here stopping potential is directly proportional to frequency. If you increase the frequency, electron kinetic energy increases. To stop that one, we should apply more negative potential. The stopping potential directly proportional. But here one more thing, independent of intensity of incident radiation. If you increase the intensity but stopping potential will not increase. Why? Because we are increasing only intensity, means number of photons we are increasing, but that photon frequency we are not increasing. So no need to increase the negative potential to stop that electron. Next, there is a time lag between the incident radiations and the emission of electrons. There is a time lag. For example, photon incident on the metal surface and electron picked out from the metal surface, but that small gap is there. The photon hits the metal plate and electron will come out. In the middle, that 10 to the power of minus 8 second gap is there, the time lag. So this is about photoelectric effect. Thank you.